Good morning, I'm Luca Gagliardelli and today I present RulER. RulER is a tool for Apache Spark that uses a novel technique that allows to find similar records by applying joining rules on one or more attributes. Sometimes we know the rules to perform the similarity join to find similar records, like in this example. By applying this rule, we are able to find the records that refer to the same entity. A rule can be composed by multiple predicates, and each one of these predicates can be performed as a single similarity join. It is interesting to note that in literature there is no existing system that tackled this particular problem, but just algorithms to perform each single piece. For this reason, we made a tool that optimized the execution of a rule composed by multiple predicates. A naive solution to execute a rule is to perform each predicate as a separated similarity join by using the existing algorithm, and then intersect or merge the results of each run according to the rule requirements. We call this solution join chain, since it is a chain of similarity join. The main drawback of this implementation is that each predicate is independently checked by the others, so the same pair can be checked multiple times also when it's not necessary. For instance, here we have that the pair d1 d4 was not needed to be checked in the second predicate, since it didn't appear in the first result set. Or we can see that the pair d1 d2 was already kept by the first part of the rule, so it was not needed to be checked in the second part. In our implementation that we called graph join, first a set of indexes is built. In particular, we use the prefix index to index the candidates. The algorithm builds one index for each predicate in the rule, and then for each record, the set of candidates is computed by using these indexes. Then, for each candidate, the predicates are proved sequentially. For example, the pair d1 d2 is proved for the first predicate, and since it passed, the others are skipped, and so for the other predicates. At the end, this led to perform less comparisons with respect to the join chain implementation. So here we can see some experimental results, and we tested some rules. Our goal is not to write good rules, but just to optimize their execution. So as you can see here, our implementation always outperforms the naive one, so the join chain. And regarding the execution time, our implementation, so graph join, is always faster, and also it performs always less comparisons with respect to the join chain implementation. And here we can see that the scalability of our implementation that is quite linear. Okay, now I show you a demo of our work. So we start by including some libraries that are needed for the execution, and then we are able to load a data set. Okay, this is a sample of EMDB, so it contains record about movies, and it's a data frame. Okay, the data are ready, so we can see, for instance, a record. Okay, so it contains the title of the movie, the year, director, the writer, the cast, and so on. Okay, so now we are able to define a rule. So for instance, this rule is composed by 6 predicates, and the syntax to write a rule is the attribute on which the rule have to be applied, the type of the similarity to use, so Jacquard or edit distance, and the threshold. Okay, this is an example of a single dataset, so we will perform a self-join. Okay, and now we are able to write a rule, so a complex rule composed by this predicate. Okay. If we want to execute these rules, so these predicates, by using the existing algorithms, so in this case we use ppjoin and adjoin, we have to combine the results of each one of these joins by using the intersect and the union operations that are available in Spark. So we can run this code. It will need some time to run. Okay, so 80 seconds to run this code and obtain the results that we can see here. Okay, so for instance, it find out that the record, that this record matches with this record, and the title is the same, and so on. Okay, so if we want to perform the same rule, but by using our implementation, so RulER, we just have to call on the data frame this method. So it's really simple with respect to this to write this code. Okay, it only needed 13 seconds with respect to 80 seconds of the other implementation, so it's faster, it's quite faster. And here we can see, okay, some results. Okay, this is another okay, example, and as you can see, these two records refer to the same movie. Moreover, our method is able to work on multiple datasets, so we are able to join multiple datasets, not only perform the self-join. So for instance, here we can load two datasets. Also, these two datasets contains record about movies. And also here the schema is different, because for instance here we have movie name, while here we have just name. Okay, so we can define another rule to perform the join between these two datasets. So for instance, we wrote a rule that say that two records are a match if the movie name has a similarity greater than 0.8, a Jacker similarity, and the actors have a Jacker similarity greater than 0.5, or the movie name is have a similarity, Jacker similarity greater than 0.8, and the directors has an edit distance lower than 2. So now we can join the datasets by using the rule that we have just defined, and then we can see the joined records. Okay, and this is an example of a match. Okay, this was just a brief presentation about RulER, so our tool that optimizes the execution of joining rules. You can find the source code on my GitHub. So this is github.com/gallia88. And if you have any question, please send me an email. Thank you for your attention.